Yeah. Hi, Karthik. I'm audible.
Yeah, Santosh.
Okay, fine. So let's continue with our next algorithm. Okay, so which is SVM. Okay, it's called support vector machines. But before that, I would like to take just 5 minutes, okay, to conclude few points regarding the classification metrics. Okay, so in our previous session, we were discussing about the ROC curve, AUC, right? So over here, just 2 points over here is I missed explaining this, right? So one thing is when we are having the threshold values, right? So over
Mm-hmm.
here we are this is for any one model. Same thing for this is some other model. This is some other model. Okay, we are taking some thresholds. So
Yes.
now here point is, for example, you are having this 0.5 threshold over here.
Okay.
So here you are having one class. Here you are having zero class.
Yeah.
Okay. So when you are having 0.5, you are saying anything greater than 0.5 is positive class. Okay. And
Mm.
anything greater than or equal to and less than 0.5, you are saying it as negative class.
Yeah.
Okay. That's fine. But now, interestingly, the whole concept of ROC is what? To change this threshold and populate new values and plot a graph between TPR and FPR.
Yeah.
Agree? That is
Yes.
what we are doing in ROC curve, right?
Yeah.
So change the threshold and get new values. So now here, when we are changing the values, what happens if you try to visualize? That is interesting. So for example, if I am taking a low threshold case, that means I'm decreasing this threshold values.
Mm.
Okay. So now, if you start decreasing these values, like if you go to 0.4, 0.2, 0.1, so what is happening? So earlier for example you have some value over here, okay, for example this is my 0.5 and next I came to 0.2.
Mm-hmm.
Okay, so now consider 0.5 case there. If you're having a particular row threshold as 0.4,
Mm-hmm.
okay, so its value will be what? 0, because less than
Yeah.
0.5.
Yeah.
Okay,
Yes.
but now our new threshold is 0.2, so this value will be 1 because
One.
it's greater than
Mm-hmm.
0.
Yeah.
Agree?
Yes.
So now what is happening? So zeros are becoming 1,
Yes.
correct? Zero,
Correct.
zeros are becoming 1.
Yes.
That means what? More and more, if you are decreasing the thresholds, okay? So here,
More
more and
positive.
more
More
values
values will
you are
be fall under
treating it
positive
as
side.
correct. So more and more values you are treating it as positive,
Yes.
correct?
Yes.
More and more values you are treating it as positive. Fine. And now, if you decrease this threshold more, that means, for example, if you say 0.1, okay,
Mm-hmm.
all the values which are in between 0.5 to 0.1, okay, which are earlier negative,
Now it will become positive.
now it will become positive.
Yeah.
Okay, so you're getting more positive value.
Positive.
Okay, so but that does not mean they're actually positive. Some could be
Correct.
positive,
Negative
some
side.
could
Yeah.
be
Yeah.
negative.
Yeah.
Okay,
Depends.
so yeah, correct. So, but all of these, whatever it is there, right? So you are
Mm.
saying it as positive.
Correct.
Okay, so but which they could not, which they are not, they not actually positive, but still you are saying
Correct.
it as positive.
Yeah.
Okay, that proportion will increase when
True.
compared to
True.
0.5.
Yeah.
Here, for example, here if you are saying 10 rows as positive, if you decrease this threshold and come to 0.1, you are saying more rows as positive.
True.
Correct? So that
True.
means this 10 might become 20.
Yeah.
20 of them are you are saying positive. But
Yeah.
in that, some of them could be actually positive. But
True.
error, some of them will be wrongly
Negative.
positive.
Yeah. Yeah.
As a whole, when you are increasing the overall count of predicting as positive, right? So your probability of predicting wrongly positive is also increasing. That means which are
True. False
not
negative.
actually positive, but you're predicting positive. That will also increase.
Yeah.
Right? So that is called FPR
Yeah. Yeah. Got it.
and
Got it.
FPR,
So
FP.
both
Okay.
will be increased.
Correct. So positive, the model is saying, but that is false positive. But just
True.
because you're decreasing the threshold, they're becoming positive.
True.
Correct. So this value is increasing.
Yeah.
Okay. But in some cases, it is actually positive. The model is also saying positive. That is also increasing.
Yeah.
TP is also increasing. Truly
True.
positive. Right. So that's why when you are decreasing the threshold, what is happening? So when you're decreasing the threshold, uh, you are having this FP is increasing.
Yes.
So if FP is increasing, so what is happening? So this FPR overall will increase because it is in the numerator, right? The
Yeah.
bigger the numerator, bigger the value.
Correct.
Okay. And similarly, your true positive is also increasing.
Correct.
Okay. So that's why TPR will also increase.
Yeah.
Right. So for lower threshold, your positives predicting the model predicting as positive are increasing. So in that, some of them which are actually positive that are also falling, and some of them which are false positive that are also falling. Right. Both
Correct.
values are increasing.
Yes.
Correct. So that's why both of these values will increase for lower threshold.
Understand.
Okay. But now if you go to higher threshold, that means now if you go to here, let's say 0.9. So
Hmm.
the reverse concept, right? So
Yeah,
over
both will be under false under
decrease.
negative side. So
Correct.
both will be decreased. Yeah, in
Correct.
this
So
case.
this particular part, which is positive with respect to 0.5, because they are greater than 0.5. Now they will become negative because these are less than 0.9.
Yeah.
Correct. So more and more ones are predicted as zero.
Correct.
Because only some which are greater than 0.1, I am saying it as 1, and remaining all of less than 0.9 are zeros. So
Yes.
more ones I am putting into zeros.
Yes.
Correct. More and more I am predicting it as negative.
Hmm.
Okay. I am predicting it as negative, but this could be false negative, or this could be true negative.
Yes.
Any negative it could be. But model is saying more negative. The outcome of negatives is more from the model.
Yes.
So Tn will also increase, but in the same case, Fn also chance there is increase.
Yeah.
Okay. So if Fn increase, FP decrease. Okay. Or you can say here what is increasing? Tn is increasing. Tn is increasing.
Hmm.
Okay. So now if you see, if Tn is increasing, okay, denominator, this value will decrease.
Yes.
Okay. And what is the other thing? Now, Fn is increasing.
Hmm.
Here also, if you see the Fn, if it is increasing,
ARP decrease.
TPR decrease.
Correct. TPR.
Okay. So that means both are decreasing.
Yes.
Okay. So in higher case, both are decreasing. In lower case, both are increasing.
Yes.
Okay. So that's why if you take lower and lower threshold, in small threshold, you will have higher values of TPR, FPR, and higher values, high threshold, you are having these values. So now in this case, then you should decide. You might think, for example, just by looking here, you can think, hey, we can go for the higher threshold values, something like this. But the problem is your TPR increasing, which is good. Okay. But your FPR is also increasing, which is bad.
Correct.
Okay. So both will moving in same direction. Okay. But if I think, okay, I will go for somewhat higher threshold, your FPR is decreasing, which is error. That is good, which is cost. That is good. But your TPR is also decreasing.
Benefit is also decreased. Yeah.
Okay. So a lower threshold value is also not going to work. A higher threshold value is also not going to work.
Yes.
Okay. So somewhere you will have. So that's why you need to test with different thresholds, and then somewhere you will get a perfect threshold where it is giving, it's called sweet spot. Okay. So where
Okay.
it will give you the required number of your
Yes.
what's called Fn and Fp values, for which
Hmm.
Fn and Fp values you are okay with. Okay. Or in your domain case, which Fn values, which threshold is giving you the lowest Fn values. Is that clear?
Yeah. Clear.
Okay. Yeah. So I would say that did we miss any other points? Let me just see. So for lower threshold points, when you are having FPR is increasing. Yeah. So usually, if when FPR is increasing, so what is increasing? FP is increasing.
Yes.
Correct. So if FP false positive is increasing, so false negative could be decreasing.
Yes.
Okay. So in our cancer case, so we want this.
Hmm.
Correct. So in our case, we want this. So we want which one? Low threshold. So for lower threshold, yeah. So you can imagine this bar in your
Yes.
slide,
Yes.
right?
Yes.
So if you're having lower threshold, more and more values you are saying it as positive.
Correct.
That means false positives are increasing. This is
Hmm.
easier way to understand, I would say. Okay.
Yeah.
So we are fine because in our cancer case we don't want false negative. So
True.
if you are increase this bar, that means what? if you put the bar over here, okay, let me
False
just
positive values will be increased.
no. If the bar is increasing, okay, if the bar is increasing, and if you put a bar over here,
Mm-hmm.
so only this part, only this small part which is above this is becoming positive.
Yeah.
But
Remain rest are negative.
okay,
False are by zero. Yeah.
bar is increasing, so more and more are becoming negative. So false negative will also
Ah.
increase.
Yes.
That we don't want.
Yes.
Okay, but if you decrease the bar and put it at let's say 0.2,
Mm-hmm.
okay, so only this particular part is negative.
Yeah. Rest
Only
are positive.
when it is 0.2, it is saying negative, but remaining all are
Yes.
positive.
Positive.
In
Yes.
this positive, you could have actual positive, true positive, or false
False
positive.
positive.
Fine. Because true positive, anyhow, we are happy. False
Hmm.
positive, this is an error, but still we are happy because our cancer case domain.
Yeah.
We don't want this FN. Okay.
Hmm.
So that's why we will decrease the threshold.
Yeah.
Okay. That one concept. So this bar, depending upon this bar, you can also easily decide like whether you should have for more threshold or higher threshold values. Sorry, lower threshold or higher threshold values. Okay. So but blindly you cannot go with the lowest one, highest one. Okay, right? Because if you go directly take the lowest value,
Yes.
right? So
The other side.
might increase. So you just need
Yeah.
to experiment and see. Okay.
Yeah.
So I
Yeah.
would say that is one thing, and quickly we'll see the code of this also. Okay. So in the taking the today morning examples of binary class, right? So we have seen the decision tree and logistic regression example, right?
Hmm.
So over here we have this for logistic model precision score. Okay, this is fine. Yeah. So correct. Once we have this ROC score, yeah. So what all we have seen? We have seen precision score. We have seen recall score, right? Yeah. Then we have something called as ROC score. Okay. So this ROC score, if you pass your values, for example, I'm passing YPRED one. That is my logistic regression.
Mm-hmm.
Okay. So you see these are the values. It will give you three values, Karthik. So one is FPR, TPR, and threshold.
Yeah.
Okay, so now if I just zip it and check the values, so last thing is threshold. Okay,
Yeah.
so the threshold it has calculated. Okay, and for two, these are the threshold.
Okay.
Okay, and for one it is 0.9 and 0.21, and for zero these are one.
Okay.
Okay, and you can see here, and you can see here for the higher values, two these values are low, FPR and TPR values.
Yes.
And for lower value, that is zero, these values are high, that is one and
Hey.
one.
Yeah.
Getting same
Yeah.
thing over here.
Mm-hmm.
Uh, Fine. Okay. So this is how you can run it, pass the ROC score. And for example, okay. So this is for the other prediction. For decision tree, these are the values.
Okay.
Okay. For logistic regression, these are the values. Oh, sorry. I need to give one. Okay. Fine. So now if you just draw a plot for this, right? So we are doing the same thing. Okay. So you are passing the ROC curve to that you are passing. So I'm just creating one code. So where I'm using logistic regression decision tree, and you are just looping through it, and you are calculating the ROC curve, FPR, TPR, and threshold values. And to that, I'm passing these FPR and TPR values to my AUC function. Okay.
Hmm.
And you're plotting. So
Yeah.
once you plot, so this is a curve it is showing.
Okay.
Okay. So as you can see for our model, so it has considered this blue color line is for decision logistic regression.
Hmm.
Okay. And for decision tree, this is some curve.
Okay.
Okay. And as you can see, the AUC, the area, because for this blue color, the area is only this much, but we are having some this extra area for
Decision.
decision tree. Okay.
Yeah.
So from that, you can also think you can say that decision trees work best.
Okay.
And inside this decision tree, which one you need to go, that you will know by checking, experimenting with different thresholds and checking those values.
Okay.
Okay, fine. I would say that is regarding this. And one important thing over here, if you observe, okay, so I'm just telling so that this will be helpful in your future classes. So you're getting this threshold, right? So this
Mm.
third one is a threshold. So threshold is 2 comma 1 comma 0 is what we got here.
Yeah.
Okay. But you might get a doubt. So, but why is threshold greater than 2? Because, for example, in our sigmoid function, so we are using threshold as
0.5.
right? And this is like a probability. The
Yeah.
maximum could be 1 and less than minimum could be 0.
Mm.
Okay. But how can we have a threshold greater than 2? Okay. Because probability cannot be greater than 1. Okay.
Yeah.
So here, the point here is for, okay, usually for the logistic regression, okay, you are having this thing between you are using what sigmoid function.
Mm.
Okay, so that will give you use some graph and that will give you between 0 and 1. Okay, but for some other uh, models, okay, but for some other models like decision tree or random forest, so
Mm-hmm.
we will use some other functions called as decisive functions.
Ah.
Okay, some functions. So where the threshold we need not to be between 0 and 1. Okay, it could be from any minus infinity to plus infinity. Okay, so that's why, but the only condition is we will put something as the bar and then we will say, hey, if it is greater than this positive, if it is less than this negative. Okay, but
Mm.
the range could be anything. Then there is no rule that it should be between 0 and 1. Okay,
Okay.
so that's why you can have threshold as 2. So that means what? If it is less than 2, you are saying it as negative. If it is greater than 2, you will say it as positive. Okay, so
Mm.
just some boundary. Okay, so for some there you will use some other functions. Okay, when we are studying that, we will see. Fine. I just wanted to show that point, but main point is how to understand what is ROC and what is AUC and how to calculate ROC, AUC values and populate and just see the graph and take a decision. Okay,
Mm.
fine.
Yeah.
Okay. Uh, yeah. With that, I would say we are good with the classification metrics. Okay. So if you have any doubts, you can let me know later. And finally, we also saw the classification report also. Okay.
Ah.
So now let's go to SVM model, okay, which is our next classification model. So as I said, in classification side, we have many models, right? So like we have logistic regression, okay, and we have SVM, we have KNN, okay, and we have Navy base, and then when we have trees, decision trees, then from this so many we get random forest and ADA boosting, XZ boost, gradient boost, all these models.
Yeah.
All of these are classification models, okay. So the first thing we studied is logistic regression. That's fine.
Mm.
Now, actually, I thought of taking KNN, but the reason for taking SVM is this is somewhat similar to logistic because just now you studied logistics, so it will be easy for you to understand SVM also.
Okay.
Okay, fine. So let's see that. To start with, let's try to understand what is an support vector machine. Okay, so why it
Mm-hmm.
is called support vector machine? So it is, as you can see here, so it is supervised machine learning algorithm commonly used for classification. Okay.
Mm.
So what happens is every classification algorithm can also be used for regression also, as I told you, right? So it can also be used for regression. Uh,
Yeah.
except for logistic, I not see logistic regression making a regression, even though it's the only uh, algorithm which is having regression in its name is logistic, but mostly we use for classification. But
Yeah.
support vector machine and decision tree mainly, they will be used for regression also. Okay.
Okay.
But mainly
Used
they
for
are designed
classification.
for classification. Okay, so it is a
Yeah.
classification or algorithm. Now, SVM constructs, yeah, SVM constructs a hyperplane or set of hyperplanes in a high dimensional space that separates the different classes. A good separation is achieved by the hyperplane that has the largest margin, meaning the maximum distance between the data points has different classes. Okay, so this is a definition. Okay, nobody will understand anything from this definition. Okay, but we'll understand what is the main concept.
Okay.
SVM, they're like only one or two basic points and everything is maths. Okay, if there is only math over here. Okay, if you
Okay.
understand this basic concept and some math, then you are good with this algorithm. Okay,
Mm.
yeah. So now basic idea over here is you are having these points. Okay, this is one class, this is another class, just like in classification. just like in logistic regression also, what was our main idea? Our main idea is to divide two different classes. There we have started with perception trick, and then we started with some play line, and finally we got a line.
Ah,
Agree?
okay.
But yeah, but the approach will vary. That is the only difference between different algorithms, right? The final
Yes.
goal is same, to
Yep.
classify. That is the fundamental goal. Okay, how you are approaching that will give you a new algorithm. That's it.
Mm.
Now, when we are having this, the concept of support vector machine, what it will do here is it will try to find out a plane. Okay, if it is in 2D, it is line. Okay, if the data points are in 2D, you can divide it by a line.
Correct.
If they're in 3D, you need a plane.
Mm.
In 4D, it is called hyperplane.
Okay.
Okay, more than 3D, it's called hyperplanes. Okay,
Okay.
so one fundamental advantage of support vector machines is it is very much helpful when your data is in higher dimension.
Okay.
Okay, we'll see at the end of this, uh, this support vector machine explanation. We'll see how it is helpful. Okay, but I'm telling you that these support vector machines are very important. Okay, when you are dealing with higher dimensions. Okay, they are very good in doing classification even in higher dimension. But logistic regression usually they'll work only in binary. Okay,
Yes.
for example, if your data, if your data, as I was saying, this is one class, this is another class. Okay,
Yeah.
no line can divide this into two different sets. Okay, using logistic regression, any line you divide, any line you draw, you cannot get a perfect classification. Agree?
Yeah.
Can you draw any line?
Perfect. No. I mean,
Yeah, if
something
here also
definitely.
this side you
Yeah.
are having positive, negative, this side also you are having positive, negative.
Yes.
Correct?
Correct.
But in support vector machine, it does. Okay. So
Okay.
how it does means it will, you know, transform this data. Okay,
Mm-hmm.
this we'll see at the end of example. Just how just to give you interest. What I'm saying is in 2D, it will try to the middle part, whatever you're having zeros, right? It
Mm-hmm.
will try to transform it into higher dimension, and it will try to move it up.
Okay. Okay. Got it. Mm-hmm.
Once you have that, so this X are in one plane and zeros are in another plane.
Okay.
Then it will divide with a hyperplane.
Okay.
Okay, so it can do
Mm.
the transformations.
Okay.
Getting so, but that is not possible in logistic regression. Okay, so that's why these are helpful. So this is
Mm-hmm.
fine. But now we did not know anything about what support vector missions. Okay, let's try to understand it basics. Oh, just a second. What have I done? Oh, yeah. Okay. So now what happens in logic support vector mission is you are having this data. Okay.
Mm-hmm.
So you want to draw a line or plane. Usually we call it as plane.
Yeah. Okay.
Assuming that we are dealing with higher dimension. Okay.
Mm-hmm.
We want to draw a plane
Okay.
such that these two data points are separated with maximum distance. Simple,
Okay.
nothing fancy.
Okay. Okay.
But how we are going to do that, that is interesting.
Okay.
See, what we do is we draw a plane which
Mm-hmm.
separates two classes, and then we draw two planes, P plus and P negative, which touches the nearest point from two classes. The minimum distance between P plus and margin, we need that plane P. That is the maximum margin. It's called maximum margin plane. What does this mean is we are
Mm-hmm.
having this class. We are having this class. Okay.
Yeah.
For example, you are saying this is positive class
Mm.
and this is negative class.
Okay.
So we want two planes. We want two
Mm-hmm.
planes. The first plane you will get from in this particular data set, negative data set, there is one point which is at the you know uh, far distance from all other points.
Mm-hmm.
Okay, that means the closest point to other data set. Let me put
Got
it
it. Got it. Got it.
the closest point to the other data set,
Yeah. And the same vice versa. Yeah.
and the same vice versa. For example, this is the point.
Yeah.
Okay, we will draw a plane which is touching this point.
Okay.
Okay, like a wall we are constructing,
Yeah.
and another plane which is touching this.
Yes.
Now, why I am focusing on only that point? Because simple thing is, if I'm able to classify this point perfectly, automatically all these are getting classified.
Yes.
Getting the idea?
Yes.
If I just say this is my line and anything to this side of the line, if I say positive class and negative class, or any class 1, okay, class 1, and this side class 2. That is good because the last point I'm if I'm doing perfect, that means remaining everything are getting automatically perfect.
Yes.
But I cannot do if example if I draw a line here and I cannot can I say that? No, I cannot say that because
No. No.
there are some points to both the sides. Correct?
Hmm.
Here also, if I just take care of this point and say, hey, all the points to this side are positive points and to this side negative points. So my whole focus will be on correctly classifying this particular point.
Okay. But
Drawing,
this is
getting
not the case every time, right? I mean, there are points which are what
some
override
points.
with these
Correct,
points.
exactly. Perfect, perfect. We will see that case.
Okay. Okay.
Okay, we'll see that case. But we'll
Okay.
start with perfect class, then we will see
Okay.
if there is imperfect data, that means there are some intercrossing, then how we'll handle that.
Okay.
Okay. But I'm glad you asked that question. Okay. We'll see that case also, definitely. Now, basically, we are starting with this point. Okay. And if we focus on this particular point,
Mhm.
everything else is getting automatically taken care of.
Okay.
Okay. So my goal is to find out these two planes.
Okay.
Okay. But instead of doing that, finding those two planes, what
Mhm.
we will do is we will find out a plane
Mhm.
which is in between of these 2 points. Okay.
Okay.
That means
Mhm.
we'll calculate this distance between these 2 points.
Okay.
Yes. Okay. And we'll bisect that distance. That means the middle point, we will draw another plane.
Okay.
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 This is called maximum margin plane. Okay.
Okay.
The distance is called maximum margin.
Mhm.
That mean that means whichever line that is whichever planes. Okay. You can draw. See, you can draw 10 planes, Karthik. Even with this,
Okay.
even touching this also, you can draw 10 different planes. Okay.
Okay.
I'm saying, see here. What I told you, touching this line, we need to draw a uh, line or plane. Okay,
Mm.
but there could be no. Oh, this could be one line. Okay,
Mm.
or this could be another line also.
Yes. Yes. Yes.
Okay,
Even straight, whatever other. Yes.
yeah, another line. Okay, and here also there could be line. Okay, and
Yeah.
here also this could be line. Okay, so there could be n number of lines I could draw, right?
Yes.
And similarly here also, and
Correct.
similarly here also. Okay, and both could be parallel also. Here I'm saying these 2 points, but for example, a slightly cross line I draw, and here also a slightly cross line I draw.
Yeah.
These two also parallel.
Yes.
Getting fine.
Yes.
So
Yes.
yeah, so like that you can have different possibilities,
Mm.
but we want that particular plane. Okay, we want that particular plane which will give you this distance, the distance between these two lines maximum.
Yeah.
If the distance is maximum, that is making sure that these 2 points are very well separated.
Correct.
Correct. And how we are achieving it by focusing on that one last point. We are taking support of those points, and with that we are separating
Separating.
all the points.
Yeah.
Okay. So that's why these 2 points are called support vectors.
Okay.
Getting?
Yeah.
And that's the reason it is called support vector missions.
Okay.
What are support vectors? The points through which we are drawing the plane.
Mm-hmm.
Okay. Parallel planes.
Yeah.
Those are the support vectors.
Mm.
Okay. And the idea is to find out those planes, those parallel planes, which have maximum margin.
Mm-hmm.
Distance call it as margin. Okay. Which is going to have the maximum margin between them.
Okay.
Clear?
Yeah.
Any doubts? One
No.
doubt you had is like if there are any interchanges, yes, that we are going to see. Apart from that, any other doubts?
And but I mean, what is the exact purpose of again we are intersecting midpoint between both because already those are I mean that is the maximum. I mean the boundary lines like support vectors are the maximum end points.
Correct.
Okay. So for the both classes, I mean
Correct.
both points. Okay. So then what is the again do we need to I mean why we need to draw midpoint of
Midpoint
those
line.
two margins? Yeah.
Correct. That's a good question. The reason is if you want this and this,
Mhm.
you need to find out two planes, equation of two planes.
Okay.
Instead of finding that, what I will do is I am bisecting this margin, okay, and getting only one plane. Okay, my job is easy. I will find out only one plane.
Okay. Okay. Got it.
From this one equation, you can again you can deduce these two planes equations because they are equidistant from that.
Okay. Got it.
Correct.
Mm.
So, but that is one thing.
Mm.
And second thing, Is this clear? Because
Yeah, 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 yeah,
I
clear.
will be, I will
So now we are
finally
not
have
now we
equation.
are not drawing those two vectors directly. Using that, we are
Correct.
creating mid plane.
Correct.
By using mid plane, we are doing rest of.
Correct. Correct.
Okay.
And also, any algorithm, any loss function will give you only one result,
Yes.
right? It cannot give you two.
Yes.
Linear regression in also logistic regression. So finally, you'll get a line
Yeah.
or plane. Okay, because we will give those values to gradient descent finally, correct, and it will minimize the values. Okay, and
Hmm.
finally get a particular value like WB, MC, etc., which will give you a line or plane.
Yeah.
So only one thing, one line you will get. So that's why it is always easy to find out only one plane.
Okay.
Okay, getting
Yeah.
that is one reason. Clear.
Clear.
Second thing, one more point. The reason why we are not using this thing is, see, this is at the border.
Okay.
Correct. So if you
Yes.
consider this as my line, anything a bit to this side will be a misclassification.
Yes. Yes. Yes.
Okay. Similarly, here also, this is the maximum.
Hmm.
Anything a bit greater than here, it will be misclassification.
Okay.
But if you consider this,
Hmm. Hmm.
have some relaxation over here.
Okay.
Okay. Even if it is falling here also, okay. Even if it is between this our plane and the maximum margin plane,
Okay.
still it is a good classification. But there is some error. Okay. But still it is not falling into here.
Yeah.
Okay, getting right.
Yes.
So as long as, but if it is, if my green point is falling in this side, for example, then that is an error because it is crossing my maximum margin line also.
Okay.
Okay, but if it is, this is my positive plane line. Okay, this dots one. This is my positive plane. Okay, and
Hmm.
this is my negative plane. For example, this is positive plane. This is negative plane. Okay, and any point to this side of this positive plane is obviously a perfect classification.
Okay.
Okay, that is obvious because
Ah.
this side you are having the points. But if it is between this line and maximum margin line, it is a
Mm-hmm.
classification, but not a perfect classification. But still, it is a, we are having some relaxation, right? Because even in future, when we are considering your case, even if some point is falling here, okay, instead of directly saying, hey, this is a misclassification, we can still say, okay, we are having this the middle plane, okay, and it is to the this left side of this plane. Still, it is a good classification, if not perfect classification.
Yes.
Okay, similarly goes to these points. Okay, so for these reasons, we are considering only one line, and our work becomes easy so that we can find out only one plane equation. Clear?
Clear.
Okay. So now the main points, if you see these points, as you know, so these the points which we are considering are called as support vectors. Okay.
Yes.
And this particular plane which touches the positive points is called positive hyperplane. And this particular dotted line which is touching this is called negative hyperplane. Okay. And the middle one is called maximum margin plane.
Okay.
Okay. And this distance is called maximum margin.
Yeah.
This is a setup. Our goal is to find out this maximum margin plane so that the distance between these two hyperplanes is maximum.
Okay.
Okay. My goal is to find out this equation of the equation of this plane. Okay. This maximum margin plane such that this distance is maximum. Correct. If I'm finding a plane which is having this much distance, that means these 2 points are very well separated.
Yes.
Agree?
Agree.
Any doubts?
No.
Fine. And almost we're near to the solution because we are saying distance, we are saying less maximum distance.
Hmm.
Okay. The obviously in with this experience like logistic linear regression you studied, so we are having there also you're having some values for whose we want maximum or minimum value, right? So obviously we can give to gradient descent, it will give you the plane equation.
Yes.
Okay, that is fine. But the story is not so easy. Okay, we will go till there, but there is some journey we need to do here.
Okay.
Okay, but I think the basic concept of support vectors, what is the approach we are doing, I think it is clear. In
Yes.
logistic regression, if you see, there also we are finding a line, there also you are having the data set, okay? But there the concept is we don't have, the concept of we are not focusing on only one point.
Yes.
We are not having any support vectors. We are considering different points or different, we are just starting with a line actually, okay? We started with some random line and We are
Slowly, we will
changing,
change the coordinates or
changing
we'll
the
change.
coordinates, checking the error. Like that, we are playing with the line itself.
Yes, yes,
Okay. Here, instead of that means what? If you start with the line and start changing, so you need to consider all the points. Okay. Every
yes,
time you change a line, each and every point equation with this line is changing. Correct, and the errors are changing, etc. But here the idea is to focus on only these 2 points called support vectors and just get the plane, making sure that once the plane is working fine for this particular point, it is automatically working for other points also. Okay, the job is a
okay,
bit easy, I would say.
okay.
Clear?
Yeah,
Okay. So just remember what are called support vectors, okay? And this is a maximum margin plane, and this is maximum margin. Now coming to the approach, so one approach we have is called as convex hull technique. Okay, so don't get scared by this name. It's called these points you have, and to this side you have these points, right? So the idea is to connect these points and create a structure. It's called convex hull.
okay.
Okay, that means if you're having points like this, okay, for
Mm.
example, you have these points, consider the outer points and just
Hmm.
connect and create a structure. That's it.
Okay.
Okay, that means the border, you are drawing a border. That's it. Okay, for India, we have border, right? So that is
Mm.
like that. This is a border for this, and this is a border for this.
Okay.
Okay, and to this points, okay, so you are finding these 2 points, okay,
Mm.
they are the closest points to each other. Okay,
Yeah.
this is the closest point to this convex hull, and this is a closest point to this convex hull.
Yes.
Correct, and draw a line between them, okay, and bisect the line. Okay, and with this point, if you pass a line plane or line or plane, usually will plane, so that is positive plane. Okay, this is a symbol of plane, Karthik. Okay, pi,
Yeah.
right, in schools
Mm.
studied, and this is negative plane. When you bisect, you are going to get the plane.
Yeah.
Okay?
Maximum. Yeah.
So now the idea is create a convex hull for positive and negative points. Find shortest line connecting both the hulls.
Okay.
The hull is hull. And bisect the line, the plane which bisects give the maximum margin plane.
Okay.
Simple?
Mm.
Okay. Now, but the equation, first we will see the equation of this plane. Okay. So equation of this plane,
Mm.
not this plane, any plane basically. What does the equation of the plane look like? Okay. Now to start with, so actually I have already reduced. So we'll start with the basic line. Okay. Then we'll understand. Are we good with this point?
Yes.
Okay. Now if you see, this is the equation of the line, Karthik.
Yes.
Y equal to mx plus b or mx plus c.
Mm.
M is slope, b is y intercept.
Yeah.
I think you are clear with this because
Yes.
this thing, if you are clear, everything is easy. Okay.
Yeah.
This is more generalized equation of a line.
Mm.
Ax plus by plus c. Okay. And
Yeah.
this is even more generalized. W1, x1,
Oh.
W2, x2. The reason is, as I said, if you're having a, b, you are having a, b. But if you have more in hyper,
More features. Yeah.
that's why you use W1, W2. So if you have more, it is just W1, W2, W3, W4. Similarly, if you're having features x, y, etc. Okay. So if you're having more features, you will generalize x1, x2, x3, x4, x5 like that. Wi, xi is the same thing what we studied in logistic regression.
Yes.
Okay, and w0. Now if you try to convert this equation to this equation, okay, the value of b, okay, here the b value here is minus w0 by w2. Why? Because
Mm.
if you see mx, so this is x1 is x, x2 is y.
Yeah.
Okay, so now if you want to write this in this form, what we will get, uh, x2 is y, right? So now x2 will be equal to what? Minus, this will go that side, minus w0, and this will also go wz minus wi xi, okay, by w2
Mm.
by w2. Okay, now this is in the form of this equation, y equal to mx plus b, y equal to, this is m,
Okay.
x plus this is b.
Okay.
Clear?
Clear.
M is what? Minus w1 by w2.
Mm.
B is what? Minus w0 by w2.
Yes.
Okay. Now what is b? B is y intercept.
Mm.
If the line is passing through the origin, can you tell me what will be the value of b?
passing through the origin,
Correct.
the slope is 0.
No, slope can see.
Right.
For example, I have this. Okay, this line is passing through origin.
Okay.
Slope is zero. No, slope is not zero.
No, no, no. Yeah, yeah. It's a 45. Yeah, like that. Yeah.
What is B? B is zero.
Okay.
B is what?
Intersection.
B is y-intercept. That means where this
It's
line is
going.
touching
Yeah,
the
yeah. It's going through 0, 0. Yeah.
getting.
Yeah.
If you have like this, so where this line is touching the y-axis, this is B-intercept.
Yes.
Okay, but if it is passing through origin, B is zero.
Mm.
Clear? Shall I explain again?
No, no, fine.
Okay. So M is slope, B is intercept. Intercept means what? Where it is touching y-axis, the distance from the
Exactly.
origin
Exactly.
to
Yeah,
that,
yeah.
that length. But it's through origin, there is no y-intercept, zero.
Yeah.
Clear? Fine. Now you are having this B equal to W0, W2.
Mhm.
Okay. This is for a, I would say, this is still the equation of a line because
Yeah.
two features we are having. Now, if you go to plane, W1, X1, W2, X2, W3, X3, three-dimensional, simple.
Mm.
Okay. Added just one more term.
Yeah.
If it is ND, then you will have W and XN.
Yes.
10 features W and XN. Because if you see, most of the time we are dealing with many features. Here, if you see 1, 2, 3, 4, 5, 6 features, etc. Okay. Features are what? X values, right? This is X1, this is X, this is
Yes.
X1, this is X2, X3, like that. Okay. Oh, sorry. Yeah. So for ND, you are having WXI. Fine.
Mm.
So that means what? Now WXI, W1, X1, W2, X2, this is the equation. Okay. This is what we are studying for next few let's say half an hour is just simple math Karthik. Okay.
Okay. Okay.
The concept is this itself. Okay. Now,
Got
now we want to find out the equation of
line using these
plane.
points and yeah.
Plane. Okay. So now if you understand this math, this is easy. So now we have this ND is this one.
Mm.
Okay. So now this equation can be written in this way. That means all W1, W2 you are having this column matrix and X is this one.
Okay.
Okay. So now this equation can be written as W dot X plus W0 equal to 0.
Okay.
Okay. Why? Because if you see, if A is this, B is
Mm-hmm.
this, then A dot B is A1, B1.
Yeah.
Okay. So for example, if I just say uh, dot product of two vectors, oh sorry, yeah, dot product of two vectors is A1, B1, A2, B2, like
Yeah.
that.
Yeah. Yeah.
So we are already having A1, B1, A2, B2.
Mm-hmm.
So I'm saying this is a dot product.
Okay.
Clear? That means if A is a column matrix and B is some other matrix, then A dot B will be A1, B1 plus A2, B2, A3, A and Bn. Is this visible, this part?
Yes. Yes. Visible.
Okay, fine. So similarly, we already have this. So I'm saying I'll consider this all W's as one W, main W, W1, W2,
Got it. Got it.
and W dot X equal W0. Clear?
Mm. Mm.
Next, we have the formula W dot X equal to W transpose X.
Okay.
Okay, so it's just formula. Okay, vector formula. So if you have two vectors, if you want to do dot product, it is similar to of doing this vector. You do transpose and just multiply with X. This X. Okay, here we are doing dot product.
Yes.
Okay, here you take the transpose of this and you do X. Okay.
Mm.
Uh, I suggest you to actually, after this, you go through uh, Khan Academy. Okay. So in Khan Academy, vectors. Okay. If you
Okay.
have any few doubts, right? So these guys explain very well. Okay. So basic vectors and basic dot products. Not the complete playlist, few concepts. Okay. So if you are getting stuck. Okay. So uh, dot product convert to transpose. Yeah, as you can see, dot product of A dot B is equivalent to matrix product of A transpose and B.
Got it.
Okay.
Mm-hmm.
So you want to do dot product, that is equal to matrix product. Okay.
Okay.
So now that's why I'm saying, hey, you are saying dot product. So I will write it as matrix products
Yeah.
plus W0.
Mm.
Okay. Clear till this point?
Yes.
Fine. So now what is W0? If you go here, my W0 is B is W0 by W2.
Correct.
Now, if this is passing through origin line or plane, my B will be 0.
Yes.
That means W0 will also be 0.
Correct.
Okay. So now we are having this equation. So I'm saying, assuming that I'm passing through origin, now W transpose X will be 0. That means because W0 is 0, here W0 is 0.
Yes.
So you lose this. So you got W transpose X equal to 0.
Hmm.
Okay. We got this. But what does this W transpose X equal to 0 means what, W transpose X is again similar to W dot X.
Yes.
W dot X equal to 0, I'm saying. That means dot product of two vectors is 0. That's what I'm saying.
Got it.
But what is the equation of dot products? W x cos theta.
Okay.
Okay. So dot product of two vectors. So if you see, uh, yeah, see A, B, cos theta, where
Cos
A
theta.
and B are magnitudes of vectors and theta is the angle between them.
Okay.
Okay? See, basically, Karthik, so if you see, for example, if I tell you what is a vector, okay, if you have this, if for example, if I'm saying A is a vector of 3 comma 4, okay,
Hmm.
and it is in 2D plane, okay, that means this is a its vector on x-axis, this is its value on the y-axis.
By axis. Yes.
That means what? For example, this is x, okay, and this is y.
3
So
and
now
4.
this is 3,
Yeah.
okay, and for example, this is 4.
Yes.
You are having this value, right?
Yeah.
This is A called as 3 comma 4.
Correct.
That means on one dimension it is having 3, on the other dimension it is having 4.
Yeah.
Okay. But what is, if you want to calculate the magnitude of
Okay.
this is what it is now. It is simple Pythagoras theorem because this is 3, this is 4 means this is also 4. Correct.
Hmm.
And what is the value of this? Hypotenuse, square root of
Yes.
3 square plus 4 square.
Yeah.
Correct. This is
Correct.
the magnitude of A, and that is
Okay.
denoted by this.
Got
Okay.
it.
So
Yeah.
vector is what? See, scalar will have only value, only
Hmm.
magnitude. So I'm saying, for example, I'm saying a brick.
Yeah.
A brick is here. What is it weight? 5 kgs weight. That is scalar.
Hmm. Yes.
But if I say a 5 kgs brick is moving in the east direction, so that is having direction and also magnitude.
Yeah.
That is vector. Okay. So here
Okay.
the magnitude is you'll get the magnitude denoted by mod A, not mod. I will say this magnitude direction. Okay, symbol, and you will get values with the square root of this. Okay, and its direction is this. This is the direction.
Yeah.
Okay. And if you're having more, for example, I'm saying in 3D plane, I'm having A equal to some 10 comma 5 comma some I don't know minus
Yeah.
2.
Yeah.
You just square it and add all this, you will get the magnitude of that A.
Correct.
Okay. So this is a vector basic definition. Clear?
Clear.
So here coming back, I'm saying we are getting W dot X. Okay. W is some vector, X is some vector.
Hmm.
Dot product, I'm saying 0.
Yeah.
That means what? The dot product equation you have seen that how you get a dot product, A magnitude of first vector, magnitude of second vector into cos theta is 0.
Cos theta.
So magnitude of W, magnitude of X into cos theta equal to 0.
Hmm.
Okay. When this will be 0, when you have the angle between them equal to 0 because theta of 90, when you have theta 90, cos 90 is 0.
Yes.
Correct? Because sine 0 is 0 and sine 90 is 1.
1.
Reverse is cos 90 is 0, cos 0 is 1.
Yeah.
Okay. So when you have angle between them is 90, then it is 0. That means if angle between them is 90, what does that mean? One vector is this and other
Yeah.
vector is this.
Yes.
So these are
Perpendicular. I mean,
perpendicular.
yeah.
Correct. Correct. So that means W and X are two perpendicular vectors.
Hmm.
Okay.
Yes.
Clear?
Clear.
Fine. But here, now it is a very interesting point. Here, what is X? X is our input.
Correct.
Correct. Now, if you go back, I am saying
Yes.
this
Yes.
is X.
Feature
What is
input. Yeah.
X1, X2? Features. Okay.
Features.
If you are considering this, for example, this sex, age, SIB, everything, these are all my features.
Correct.
Okay. So, considering all these features, whatever the plane you are having, right? So, that plane is my X plane.
Yeah.
Okay. That is my plane X.
Yes.
And W is what? W is the coefficients of this plane.
Yes. Yes.
That is also having a plane. That
Yes.
W is perpendicular to my X.
Correct.
That is what it is saying. Okay. So for example, if you have my x as this one, okay, if you have x as this one, fine. So whatever the plane you are having, the W plane, that is perpendicular. Somewhere it is perpendicular.
Yeah.
Okay, but this complete plane is my plane X. In this, one could be my X1, X2, X3, X4 in n-dimensional. So all those X you are having a particular plane. Okay, all those if you consider it as a plane. Okay, now this W is perpendicular to the complete X plane.
Yes.
Okay, that plane. Getting?
Getting.
Okay, so that is what we need to understand. So this max is fine, but finally, what that this equation is saying? This equation is saying my W, whatever the vector W vector we are getting, the coefficients vector, that is perpendicular to my input vector. Input vector is x. Okay,
Okay.
because Wx equal to 0. Clear?
Clear.
Fine. Now this is what a basic equation of line plane we are getting. Okay. Now coming back to SVM, what we are having? We are having we need to find out this distance. Sorry,
Yeah.
this plane. Okay.
Yes.
So if you consider this one support vector, this is another support vector. Okay. This is some distance d1. This is my distance d2. Okay. Now, if you see this equation of the line, I'm saying Wx plus b equal to 0. General equation. Okay.
Hmm.
Same thing. Wx plus W0 or B or W naught, b equal to 0. If it is passing through origin, obviously this will be 0. Okay.
Hmm.
But we don't know. So we are considering it as this is the equation.
Hmm.
Okay. Now, this particular point, okay, to one side, I am considering a plane as W transpose X plus B
Hmm.
equal to 1. Okay, greater than or equal to 1. That means I am considering this distance. Okay, I am
Hmm.
considering this distance as 1.
Yeah.
You can consider, actually, you can get it down. Why 1? So you will see in the formula, you can consider anything. But this distance is equal to this distance
Yes.
because this is bisecting. This plane is bisecting.
Yes.
Okay. So to one side, I am saying a plane equation W transpose X plus B is greater than or equal to 1. And to other side, I am saying W transpose plus B equal to less than or equal to
Less
minus 1.
than or equal minus one. Okay.
Okay. For example, this is positive class, this is negative class. I am saying this is a plane for the positive class, this is a plane for the negative class. Okay.
Okay.
So here, if you take 10, this will become 10,
Yeah.
20, 20. So anything you can take in the formula you
Got.
will see. So, but
Got.
simplicity, we are taking 1.
Hmm.
Clear?
Yeah.
Okay. So everything we started understanding. So basic equation of the plane. What is the basic equation of plane is we saw it from here. Okay. This is general equation of the plane. Any
Yeah.
plane take WX. Okay. So it will be W transpose X. Okay. Plus B. And from this, so that's the reason you asked, right? So why we are calculating instead of calculating these two planes, why we are calculating one plane? The reason
Hmm.
is this. We understood the equation of the plane. From this plane, we got these two planes.
Yeah.
Okay, so I'm saying this is 1 and this is minus 1. Okay,
Yeah.
now if you see this distance, if this is, for example, this is here, if it is 1, that means what? For this support vector, okay, for this support vector, it is 1. For other
Hmm.
than support vector, for example, this, it is greater than 1. Agree? From this plane, the first line that is touching this plane is support vector.
Yeah.
That for that, the distance is 1.
Hmm.
But there are some other points also, right? So, but from this plane, this is more greater than 1.
Correct.
Okay. If it is again on the plane, it is 1. Okay.
One.
Here it is slightly greater than 1. Greater
Correct.
than 1. Greater than 1. Getting?
Yeah. Yeah.
So that's why I'm saying W transpose X is greater than or equal to 1.
Correct. It might be on the line or it might be
Oh,
out of.
exactly.
Hmm.
For support vectors, it will be 1.
Yeah.
For not necessarily only one support vector. In some case, you can have more support vectors also, right?
Yeah.
So in that case, you will have greater than 1.
Hmm.
Okay. So now coming to this particular point, this distance is minus 1.
Yeah.
Okay. For other points, it will be greater than, sorry, less than minus 1.
Yeah.
Okay.
Understand.
Fine. So that's how you got 3 plane equations.
Okay.
Okay. So now note that this W transpose X,
Mm-hmm.
okay, for positive plane, it will be 1. And for this particular points, it will be minus 1.
Okay. Yeah. Yeah.
For this support vector, here it will be minus 1. Correct?
Okay. Yeah.
Now, next thing what we're doing is, so we are having these two planes. One is this equation, this is the equation. So we will club these two equations
Mm-hmm.
and write into one equation, that is same thing, W transpose X plus B, but we are just using this Yi. What is
Okay.
Yi? Class.
Yeah.
Class or negative class.
Yes.
Okay, and greater than 1. This is one equation. So
Mm.
if you see, for example, if it's a positive class,
Mm-hmm.
Yi will be 1.
Yeah.
Then what is the equation? Can you tell me?
Complete a entire equation greater than or equal to 1.
Correct?
Mm.
Which is same as this one.
Yeah.
Okay. If it is negative, what will be this? So this will be minus of
Yeah. Yeah.
transpose
I
X
mean, if
B
minus goes the right
minus
side, it
1,
will be less than or equal to.
or this will be less than or equal to 1.
Yeah. -1.
Same, minus 1.
Mm.
Same as this.
Correct.
Correct? So instead of using 2 and 3, I'm using only one equation.
Yeah. Yeah.
Clear?
Yeah.
So we started with some equation plane. From that, we got two support vector planes. Okay. And we clubbed those two into one.
Yeah.
Okay. Next, what we are going to do is we just need the distance of D1 and D2 as max.
Yes.
Okay. So we separate the equation of this plane, okay, from this plane. Okay. What is the distance between 5 and 3? 5 minus 3.
Huh.
2, right? Similarly, we'll subtract these two equations. Okay. What is
Yes.
the equation? One equation is W transpose X plus B equal to 1, and W transpose X2 plus B equal to -1.
Huh.
Okay. Now what we are going to get, double x1, x2, y. This is some other point. This is some other point. Getting the points of this. See, for example, if you consider this is one support vector, right? This is x1.
Yes.
This is x2.
Yes.
Okay. So here W transpose x1 plus b is 1. I'm considering this equation plane.
Mm-hmm.
And for this is x2. W transpose x2 plus b is equal to -1. So
Yeah.
I'm saying equal to and equal to. Why? Because those are, I'm not saying greater than or equal to 1. I'm not saying less than or equal to 1. I'm directly saying equal to 1, equal to -1. Why?
I mean, equal to those are above the. It's on the line because
On
of
the line, right?
on the
Those
line.
are support vectors.
Yeah. Okay. On the
So
line.
here I said, if the, see, W transpose X is greater than 1, Karthik,
Yeah. Yeah.
greater than or equal to 1.
Hmm.
For support vectors, it will be exactly equal to 1 because
Yes. Yes.
this is the distance, right?
Correct.
This is the distance. Because of support vectors only, we started this line and this line.
Yeah.
And for this vector, it will be exactly equal to 1.
Yeah.
And for this vector, support vector, this will be exactly equal to -1.
Yes.
For this all other points, the distance will increase. That's why it could be greater than 1. That's why I wrote greater than 1.
Okay.
For all these points, the distance might again less than this distance. So that's why I'm saying less than -1.
Hmm.
Okay. But for vectors, as I said,
Yeah.
note that these values will be exactly equal to 1 or -1 for
For
only
support the vectors. Yeah. Yeah.
clear. So that's
Clear.
why when I'm considering this point, x1 and x2 point, I am considering the equation as this
Equal to 1. Equal to
minus
-1.
1.
Yeah.
Clear? Any doubts?
No. 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 No.
Perfect.
Yeah.
Okay, so now we are subtracting this. So when you subtract this, so you will have W transpose x1 minus x2,
Mm-hmm.
okay, and B gets cancelled,
Yeah.
equal to 1 minus of -1, it is 2.
Yeah.
Clear? W transpose you will take as common, x1 minus x2 equal to 2.
Yes.
So now this is my point. Okay, now when we divide this, okay, when we divide this by magnitude of W, you will get
Hmm.
a unit vector. Okay.
Okay.
So if you don't understand what does this mean is anything, any vector, for example, A. Okay.
Hmm.
When we say this is a symbol of vector, that
Yeah.
means what it is saying, this is scalar A, this is
Yeah.
scalar.
Yeah.
That means I'm not putting anything, that means it is not having
Yes. Yes.
direction,
Yes.
it is having only
Yes.
magnitude.
Magnitude.
I'm putting direction, that means it will have magnitude
Direction plus
and also
magnitude.
direction.
Yeah.
Okay. But what happens here is this is the direction of this vector.
Hmm.
Okay.
Yeah.
Interesting point in vectors is in this direction, Karthik, you can have many vectors. See, this is
Correct.
one
Correct.
vector.
Correct. 1 comma 1 or whatever it will
Correct. This
intersect.
is also another vector in the same direction. But what is
Correct.
changing?
Just a magnitude is changing.
Magnitude is changing. Perfect.
Yeah.
Okay. This is one more vector in the same direction.
Yeah.
Same direction of this. But magnitude is changing.
Yeah.
Okay. That similarly, any vector can be converted into a unit vector. And unit
Hmm.
vector is nothing but with a magnitude of 1.
Got it.
Okay, with a
Yeah.
magnitude of
1.
1. So that means what? A unit vector of A, if A is a vector,
Mm-hmm.
if you want to get unit vector, you need to divide A by magnitude of A.
Okay.
Then whatever you are going to get, that is unit vector. Why? Simple. For example, if you see here,
Mm-hmm.
what is the equation of A? A is 3 comma 4.
Yeah.
Now, if you divide this 3 comma 4 by magnitude of A, what is magnitude of A?
Uh,
What is the
sir,
formula for magnitude of A?
magnitude of A. It's I mean,
This one.
correct. That slope. We need to find out that distance from point to 3
Correct.
comma 3 comma 4.
Correct. Correct. But see, if this is 3,
Hmm, hmm, hmm.
this is 4,
Yeah.
what
So
is this?
it's a triangular, like trigonometry thing.
Correct. Pythagoras.
Pythagoras, yes.
This is hypotenuse, right?
Yes, 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 yes.
So
Hypotenuse.
this will be square root of
Hmm, hmm,
3
hmm.
square plus 4
Plus 4
square.
square. Yeah.
Clear?
Yes.
That is magnitude. What is this 3 square plus 4 square? How much it will be? 9
25. 5. Plus or minus 5.
plus plus or minus 5.
Yeah.
Okay. So this is 5. Okay.
Hmm.
Now, s- square root is always positive, I think.
But we indicate plus or minus.
Plus or
Uh,
minus.
plus for roots and all.
Okay. Done. Done.
More. Hmm.
Done. Okay. So this is 5. Okay.
Yeah. Yeah.
Now, magnitude of this is what? 5.
Yeah.
Getting? So if
Hmm.
you have the coordinates of 3 comma 4, how to find out the magnitude is you need to use this formula.
Correct.
You got 5. Now
Yeah.
what I'm saying is, if you are having this magnitude and A
Mm-hmm.
is a vector is A 3 comma 4 is a vector with a magnitude of 5.
Yeah.
Now we have this direction. Now if you find out the unit vector of A, that means what?
Mm-hmm.
When I'm saying unit vector of A means find out a vector in the same direction of A but with a magnitude of 1.
1. Okay.
That's why it's called unit.
Yeah.
How you will get? Just divide A by magnitude of A. So what is my A? A is 3 by
Mm-hmm.
comma 4. So what is magnitude of A? 5. So 3 by 5 by 3 by 5.
Okay.
Sorry, 3 by 5, 4
4
by
by
5.
5.
Now, what is what? This is another vector. Okay.
Yes.
Now, what is the magnitude of this? Can you tell me? Same formula. Whole square of 3 by 5 whole square.
Plus 4 by 5 whole square.
Now, can you tell me what will be this? Square root of denominator will be 25.
Mm-hmm.
This 9, 3 square, 9, 4 square,
9
16,
plus.
25.
Yeah. 25.
1.
1.
What is the magnitude now?
1.
That's why it's called unit vector.
Okay. Got it.
Okay. So how you will get this? Just divide the vector by its magnitude.
Got it.
The resultant will be a unit vector of that A.
Yeah.
Okay.
Yeah.
This is unit vector for only A. That means only in this direction.
Yes.
For some other thing, it will be. But when you say unit vector, the magnitude is 1. Direction, we don't know.
Yes.
But because we are using the same A,
Mm-hmm.
the direction will also be in the direction of A, but magnitude is only 1.
Yeah.
But for A, the magnitude is 5.
Yes.
Okay. Fine. So we just need. So we'll stop in just 1 minute. So
But why we are considering only one a unit vector? Is
yeah,
there
that I
any?
will tell. That I will tell you. That I will tell you.
Okay.
Okay. So now we'll just discuss this point for the session. So now here the point is we are having this, right?
Mm-hmm.
So what we are having? So we are having this x1, x2. Okay.
Yeah. Yeah.
So what we want, the x1 and x2 distance.
Correct.
Okay. So but we are having this another vector
Hmm.
along with it.
Hmm.
Okay. So that's why we'll divide it by its magnitude.
Okay.
So it will become unit vector.
Got it.
Then what you will get is only x1 minus.
1. We will get only 1 over there. Yeah. Okay.
Okay.
Yeah.
Yeah, we'll get 1 over here.
Yeah.
Okay. So now x1 minus x2. So this is this. Okay.
Mm-hmm.
W transpose x1 minus x2 equal to 2. So we divide both sides by
Okay.
magnitude of this W. Okay. So now x1 minus x2 becoming this as a unit vector.
Mm-hmm.
The distance is 2 by magnitude of W.
Okay.
Okay. Getting?
Yeah.
So this is the magnitude between two vectors, 2
Yeah.
points, x1 and x2.
Okay.
Okay. The distance between these 2 points, okay, the
Mm-hmm.
distance between x1 and x2, okay,
Yeah.
this distance,
Got it.
okay, that is what? 2 by magnitude of W. Now,
Hmm.
W is what? W is the coefficient matrix, whatever we are having, right? So this is my W.
Okay.
So if you get a plane, a perfect plane whose values are W and W2, and if it is okay, we don't know whether it is perfect plane, but we want that plane
Hmm.
whose values are W1, W2, such that when
Hmm.
you calculate the magnitude of this
Okay.
and you do 2 by magnitude of that one, that value
Mhm.
should be maximum.
Okay.
We want that plane
Got it. Got it.
such that that plane will give you the maximum distance between these 2 points.
Yeah. Yeah. Yeah.
Clear?
Hmm.
Okay. But this equation is valid only
For that particular.
when you have this one. Okay.
Yeah.
What we assumed that y1 dot w transpose x plus b is greater than 1. That means what? That means what? The same thing which you asked initially. That means we assumed that there are perfect data points. That means the data
Hmm.
points are getting perfectly classified.
Correct.
When we are considering this point as x2 support vector, that means we are assuming that every point to other side of these are only one class.
Yes. Other point. Both are separated
Both are
already.
perfectly separated.
Hmm.
Okay, we are assuming that. Okay, this
Yeah.
equation is saying that. So with that, we did the distance between two planes and we got 2 by mod w.
Hmm.
Okay, so now we understood the distance is
Hmm.
the distance formula is 2 by mod w
Hmm.
such that this one, okay, we want that plane which
Hmm.
is giving 2 by the coefficient magnitude is
Yeah.
maximum, but with the condition. Okay, this is called constrained equation. This is not a
Okay.
normal equation. First of
Okay.
all, that plane should satisfy this one, Karthik.
Okay.
Okay? So if we have some plane which is giving the maximum value, but if it is failing this, we don't want that. That means what? It is doing some misclassifications.
Okay.
Correct? What is this speaking about? This is speaking about perfect classification.
Yes.
But if this is failing, if this is less than one, that means what? Somewhere this green point is going here, blue point is coming here.
Correct. Correct. Correct.
Okay. So we want both the things. We want that plane which is giving maximum value of this following this condition.
Yeah.
Clear?
Yeah.
Okay. So now this above, whatever we got it right. So that is called as SVM hard margin. Okay. It's
Okay.
a hard margin because we are saying that there should not be any misclassifications.
Hmm.
This will work only when the data is perfectly, almost perfect separable.
Okay.
Only in that case it will work. Okay. But in real life, it is very hard to find such data
Yes.
because as you said correctly, we'll have
Yes.
some misclassifications.
Hmm.
So that's why this will not work all the time. So that's why we have something called a soft margin.
Okay.
Okay, that means we'll do some adjustments to this equation so that we are okay with some misclassifications.
Mm-hmm.
Okay, in that case, what should be my line?
Okay.
In that case, what should be my equation? What are my
Okay.
equations? What are my
Okay.
constraints? That we'll see in tomorrow.
Sure.
Okay, but I hope this
Yeah.
concept is clear. Just understand for hard margin. Okay, the magnitude, the distance, whatever you are going to get is 2 by mod of W.
More W.
And we want this value to be maximum value.
Yeah.
Okay, because this is distance.
Correct.
Okay, mod value. For example, if I just reverse this mod W by 2, we want this value to be
More W by 2.
for 2 by mod W is max,
Yeah, it will be minimum.
minimum value.
Yeah.
Okay,
Mm.
that is the difference. Okay, I would
Yeah.
say that's all for today. But I hope you understood.
Mm.
Right? So we'll see tomorrow, the remaining
Sure.
session.
Sure.
Okay,
Yeah.
thanks.